What if every second that passes through your awareness is actually flowing backward, and the future you're moving toward has already happened in dimensions your mind cannot perceive? You exist in this moment, reading these words, breathing this breath, while time itself might be nothing more than an illusion created by consciousness trying to make sense of a universe where past, present, and future exist simultaneously in an eternal, unchanging now. Tonight, you're about to discover that time isn't what carries you forward through life, but what life creates as it tries to understand itself. What exists when existence has no when? Before the universe learned to count its own heartbeats, before space discovered distance and matter found form, there stretched an eternal moment that contained every moment while being none of them, a paradoxical state where time waited to invent itself from the mathematics of pure possibility. The beginning? There was no beginning, no moment when time decided to start flowing like a cosmic river, no universal clock waiting to be wound by some celestial hand. The very concept of commencement requires duration to give it meaning, yet duration itself had not yet been born from the quantum foam of potential that filled an existence without extension or sequence. Time itself was unborn, existing only as pure potential in a realm where the concepts of before and after had no meaning, because meaning itself required temporal relationships to distinguish one state from another. This was the temporal equivalent of absolute zero, not the absence of heat, but the absence of the very dimension in which heat could flow from one moment to the next. The universe held its breath in a state beyond duration, suspended in a condition that transcended every human intuition about the nature of existence and sequence. Every possibility that would ever unfold across billions of years of cosmic evolution waited in perfect, timeless suspension, not as a collection of events queued up for their turn, but as a single, infinite potential where all outcomes existed simultaneously without precedence or succession. This primordial state was not emptiness, but infinite fullness compressed into a mathematical point where past, present, and future were indistinguishable from one another. Imagine trying to determine the sequence of events within a geometric point. The question becomes meaningless because sequence requires extension, and a point has no internal structure across which relationships of before and after could be established. Within this realm beyond time, quantum fluctuations danced without rhythm because rhythm implies repetition across temporal intervals that had not yet learned to exist. Energy pulsed without sequence because pulsation requires the alternation between states, and alternation can only occur when time provides the framework for transition from one condition to another. The laws of physics themselves existed in a dreamlike state, carrying within their mathematical structures the templates for temporal relationships they had not yet learned to measure. Einstein's equations contained the possibility of space-time curvature, while quantum mechanics held the blueprints for uncertainty relations that would define the temporal limits of measurement. Yet these laws remained dormant, like sheet music waiting for an orchestra that had not yet been assembled. Even more mysteriously, within this temporal void, the seeds of all future seconds lay dormant like cosmic DNA, carrying within their quantum information the blueprints for every heartbeat that would ever mark the rhythm of biological existence, every sunset that would ever measure the rotation of planets not yet formed, and every fleeting thought that would ever arise in minds that would not exist for billions of temporal cycles yet to come. The quantum vacuum fluctuated with virtual particles that borrowed energy from the cosmic ledger and repaid it faster than any conceivable clock could measure. Yet these transactions occurred in a realm where the very notion of faster than had no referent because there was no temporal scale against which speed could be calibrated. Time was preparing to discover itself through the ultimate paradox. It would have to create duration in order to experience the process of its own creation, emerging from timelessness through a transition that could not, by definition, take any time at all. The stage was set for the greatest magic trick in cosmic history, the appearance of when from nowhere. The transition from timeless potential to temporal reality marked the universe's first and most fundamental act of creation, not the making of matter or energy, but the invention of the very dimension in which making could occur, where cause could precede effect, and where existence could learn to tell its own story. The emergence from the timeless void was not an event in the conventional sense, because events require time to occur within, and time itself was what was being born. Instead, this was the universe's discovery of its own capacity for change, the awakening of duration from the mathematical possibilities that had been dreaming of sequence without ever experiencing succession. With the first expansion of space came the first heartbeat of time, as the universe learned to distinguish between now and then in the most fundamental way possible. This was not simply the beginning of temporal flow, but the creation of the very framework that would allow the concepts of beginning, middle, and end to have meaning. Space and time were born as inseparable twins, with each expansion of spatial dimensions creating corresponding extensions of temporal duration. Duration was born not as a river flowing forward from past toward future, but as the stretching of existence itself across dimensions that had never before known sequence or succession. Time did not flow through the universe like water through a pipe, but emerged as the universe's capacity to be different from moment to moment, to support change and transformation rather than eternal static perfection. Each moment of cosmic inflation created new territories of time, expanding the temporal landscape, where events could finally arrange themselves in order rather than existing in eternal simultaneity. The exponential growth of space during inflation was simultaneously the creation of temporal extension, with each doubling of cosmic size providing twice as much temporal room for causality to operate. As space-time unfurled from its initial singularity, the universe began keeping its own records for the first time in cosmic history. The cosmic microwave background radiation became time's first autobiography, writing the history of expansion in electromagnetic wavelengths that would forever carry the timestamp of creation like fossil light, preserved in the amber of cosmic time. Temperature gradients emerged as the first temporal signatures, with cooling rates providing the universe's initial clock mechanism. As expansion reduced energy density, the dropping temperature marked the passage of cosmic time with thermodynamic precision, creating the first reliable chronometer that would tick away the eons of cosmic evolution to come. Causality awakened as effect, learned to follow cause, establishing the fundamental rhythm that would govern everything from quantum interactions operating on Planck timescales to the formation of galaxies across billions of years. This was not merely the establishment of temporal order, but the birth of logical sequence itself, the cosmic principle that would make science possible by ensuring that results followed consistently from their antecedents. The speed of light emerged as time's fundamental constant, establishing the maximum rate at which causal influence could propagate across space and defining the temporal structure of relativistic physics. Light became time's messenger, carrying information from one moment to the next, and creating the causal connections that would weave individual events into the coherent narrative of cosmic history. Quantum uncertainty introduced temporal fluctuations that would make the flow of time probabilistic rather than perfectly deterministic, adding an element of creative unpredictability to cosmic evolution. The uncertainty principle established fundamental limits on temporal precision, ensuring that the future would remain genuinely open rather than completely predetermined by initial conditions. Learning to expand, space had taught time how to flow, creating the vast arena where all future stories would unfold across the cosmic stage. Duration had become the universe's gift to itself, the dimension of possibility where change, growth, evolution, and eventually consciousness could emerge from the simple but revolutionary discovery that existence could be different from one moment to the next. The expanding universe that had learned to stretch time across cosmic distances was about to discover something extraordinary, that duration could be measured not just by the grand scales of cosmic evolution, but by the infinitesimal vibrations of matter itself, where the smallest constituents of reality would become the most precise timekeepers ever conceived. As the cosmos cooled from its initial state of pure energy, temperature dropped sufficiently for the first stable particles to condense from the quantum foam like morning dew, forming from invisible water vapor. This transition from energy to matter was simultaneously the birth of time's first mechanical clockworks, as particles acquired the regular, predictable behaviors that would make precise temporal measurement possible for the first time in cosmic history. The universe cooled and particles began to form. Time found its first reliable witnesses, tiny clocks made of quantum energy that would tick with the fundamental frequency of reality itself. These were not clocks in any conventional sense, but quantum oscillators whose very existence depended on the regular exchange of energy packets in precisely defined amounts that would become the basic units of temporal measurement. Electrons discovered their orbital rhythms around atomic nuclei, creating the first precise timepieces in cosmic history, as they absorbed and emitted photons with clockwork regularity that surpassed any mechanical device humans would ever construct. Each electron's orbit was a quantum metronome, maintaining its energy states with such precision that atomic transitions could serve as the ultimate temporal references for measuring all other forms of change and duration. The formation of hydrogen atoms marked the emergence of the universe's first standardized chronometers, with each electron's transition between energy levels releasing or absorbing photons of exactly defined frequencies. These quantum beats became nature's fundamental time signatures, establishing the basis for all atomic clocks and creating temporal precision that would remain constant across billions of years of cosmic evolution. Each quantum transition marked a moment with mathematical precision, establishing the deepest level of temporal measurement where time revealed itself as discrete rather than continuous like the flow of a river. Time was not smooth but granular, composed of indivisible quantum moments separated by energy gaps that could not be subdivided further, much like matter was composed of discrete atoms rather than continuous substance. Atoms became living chronometers, their energy levels stepping up and down in quantum beats that divided time into its smallest possible units. The Planck time emerged as the fundamental temporal quantum, the briefest interval during which anything could occur, beyond which the very concept of shorter duration became physically meaningless, because there was insufficient time for light to cross the smallest possible distance. The uncertainty principle introduced its own temporal music to this quantum symphony, creating a paradox where the more precisely scientists tried to pin down the moment of a quantum event, the more elusive that moment became. This was not a limitation of measurement technology, but a fundamental feature of reality itself, where time and energy were locked in an intimate quantum dance that made perfect temporal precision forever impossible. Quantum tunneling revealed that particles could appear to traverse barriers in zero time, or even negative time, suggesting that the relationship between cause and effect might be more flexible at quantum scales than classical physics had assumed. These temporal anomalies hinted at the strange non-local nature of quantum reality, where the normal flow of time could be suspended or reversed under certain conditions. Within the dance of subatomic particles, time showed its dual nature, both fundamental to reality's structure and mysteriously resistant to complete understanding. While atomic transitions provided the most precise temporal measurements possible, the quantum realm simultaneously revealed that time itself might be more mysterious and paradoxical than any classical conception could capture. The particles had given time its rhythm, ticking away in quantum increments, while remaining beautifully, eternally enigmatic, precise enough to measure cosmic evolution, yet strange enough to challenge every human intuition about the nature of temporal flow and the relationship between measurement and reality. The universe that had been opaque since its birth was about to achieve transparency, marking one of the most significant moments in cosmic history when time would finally be able to travel freely across space, carrying messages between distant regions of space-time that had been isolated in their own temporal bubbles since the beginning of expansion. For nearly 400,000 years after the initial expansion began, the cosmos had been filled with a dense plasma, where photons could travel no further than the width of an atom before being scattered by free electrons. Time itself was trapped in this cosmic fog, unable to propagate information across significant distances because light, time's natural messenger, was constantly being redirected in random directions by the charged particles that filled all of space. This period of cosmic opacity meant that different regions of the universe were effectively isolated in their own temporal domains, unable to coordinate their clocks or share information about their evolutionary progress. Each location experienced time in isolation, like remote islands cut off from communication with the rest of the cosmic archipelago. The transformation came when cosmic expansion finally reduced temperatures below the threshold where electrons could be captured by atomic nuclei, creating the first stable hydrogen and helium atoms. This recombination event suddenly made the universe transparent to electromagnetic radiation, as neutral atoms were far less effective at scattering photons than the free charge particles that had previously filled space. The liberation of photons from the cosmic fog marked time's first great journey as light began racing across the expanding universe for the first time, carrying temporal messages from distant regions of space and time that had been developing in isolation for hundreds of thousands of years. This was the moment when the universe became a connected whole rather than a collection of isolated temporal domains. Light became time's messenger, encoding moments from its origin in the wavelength and frequency of electromagnetic radiation that would travel for billions of years before reaching distant observers. Each photon carried within its electromagnetic signature a precise record of the conditions at its point of emission, preserving temperature, density, and energy information like a temporal fossil embedded in the fabric of spacetime itself. Each photon carried a timestamp from its birth, preserving the moment of its creation in its energy signature, while simultaneously stretching through cosmic expansion, redshifting its frequency as space itself aged around it. This cosmic redshift became a direct measure of temporal distance, with more ancient light being stretched to longer wavelengths that revealed how much cosmic time had passed since the photon began its journey. The cosmic microwave background became the universe's baby picture, frozen in time, yet still arriving fresh each moment from every direction in space. This ancient light provided a temporal snapshot of cosmic conditions at the moment of recombination, demonstrating how time and light were intimately connected in the fabric of space-time, where electromagnetic radiation served as both temporal record and temporal transport. The newly transparent universe revealed that information could not travel instantaneously, but was limited by the speed of light, establishing the cosmic speed limit that would govern how fast causality could propagate across space. This fundamental constant created a temporal structure where events could only influence each other within light cones, regions of spacetime that could be reached by signals traveling at the maximum possible speed. Light's finite velocity created time zones on cosmic scales, where distant events would always be seen as ancient history, with the most distant galaxies appearing as they existed billions of years ago, when their light began its journey across the expanding cosmos. The universe became a vast temporal archive, where looking deeper into space meant looking further back in time. Through the liberation of light, the cosmos had discovered how to create permanent temporal records and establish causal connections across vast distances. Light had become time's first historian, preserving the moments of its creation while carrying them across the expanding universe to future observers who could read the temporal messages written in electromagnetic frequencies and cosmic redshift. Gravity began gathering the scattered hydrogen and helium from cosmic recombination into concentrated masses that would become time's next great innovation. Stellar furnaces where nuclear fusion would create the most precise and long-lasting chronometers the cosmos had ever produced. As cosmic expansion continued and matter began collecting into the first gravitational wells, the stage was set for a new chapter in time's evolution. The smooth distribution of primordial gas started developing structure as density variations grew under gravity's patient influence, creating regions where matter would concentrate sufficiently to ignite the nuclear processes that would define cosmic time for billions of years to come. The first stellar nurseries formed in these gravitational gardens, where gas clouds collapsed under their own weight, heating up through compression until their cores reached the critical temperatures needed to overcome the electromagnetic barriers that kept atomic nuclei apart. These collapsing gas clouds were time's laboratories, where the universe would learn to harness nuclear energy and create temporal cycles of unprecedented precision and duration. Within the first stars, nuclear fusion created the most reliable clocks the universe had ever known, as hydrogen nuclei merged with rhythmic precision that would mark cosmic time for billions of years with far greater stability than any quantum oscillation or cosmic expansion rate could provide. The stellar cores became vast chronometers operating on entirely new temporal scales that bridged the gap between quantum time and cosmic time. Stellar cores became vast chronometers where the steady burning of nuclear fuel created predictable sequences of energy release, establishing timescales that dwarfed anything in the previous universe, while providing temporal landmarks that could be observed across vast cosmic distances. Each fusion reaction followed the same nuclear physics, creating standardized energy outputs that could serve as cosmic calibration standards for measuring astronomical time intervals. The nuclear burning proceeded through predictable stages, with each stellar mass following a predetermined temporal script written in the laws of thermodynamics and nuclear physics. Hydrogen burned to helium in the stellar cores, then helium fused to carbon and oxygen, with each phase lasting for precisely calculable periods that depended only on the star's initial mass and composition. Each star's lifetime was written in its mass and composition like a cosmic birth certificate that predicted its entire temporal trajectory, creating a cosmic calendar where stellar evolution marked eras and epochs across galactic time. Massive stars lived fast and died young in spectacular explosions, while smaller stars like red dwarfs would burn steadily for trillions of years, outlasting all other known cosmic processes. The pulsing of variable stars added rhythmic beats to cosmic time, with Cepheid variables oscillating with periods that could be measured from across intergalactic distances, while pulsar neutron stars would later provide the most precise natural clocks ever discovered. These stellar timepieces created a hierarchy of cosmic chronometry that spanned from seconds to billions of years. The explosive deaths of massive stars created temporal landmarks that could be seen across intergalactic distances, with supernovae marking specific moments in cosmic history, while simultaneously scattering the heavy elements created during stellar nucleosynthesis throughout the surrounding space, seeding future generations of stars and planets with the chemical diversity needed for complex chemistry. Through stellar nucleosynthesis, time became an active creator rather than a passive observer, forging the elements that would eventually enable more complex forms of timekeeping. The carbon, oxygen, silicon, and iron created in stellar cores would one day become part of planetary systems, biological clocks, and conscious observers capable of contemplating their own temporal existence. Stars had transformed time from a passive dimension into an active force of cosmic creation, demonstrating that time was not merely the stage for events, but a participant in the creation of complexity itself. Through nuclear fusion, stellar evolution, and element creation, time had learned to build the chemical foundations for all future complexity, while maintaining cosmic chronometry across scales from stellar lifetimes to galactic evolution. While stars were establishing their nuclear chronometry across the cosmos, a deeper truth about time was waiting to be discovered, one that would reveal duration itself as malleable and flexible, shaped by the very masses that stellar fusion had created and the gravitational fields that held galaxies together in cosmic embrace. For centuries, time had seemed like the one universal constant that all observers could agree upon, flowing steadily and uniformly throughout the cosmos, regardless of location, motion, or the presence of matter. This intuitive understanding suggested that time was the absolute backdrop against which all events occurred, independent of the physical processes that unfolded within its steady flow. The breakthrough came through Einstein's profound insight that space and time were not separate, independent dimensions, but woven together into a unified fabric that could be warped, stretched, and curved by the presence of mass and energy. This revolutionary understanding transformed time from an absolute constant into a dynamic, flexible dimension that responded to the gravitational influence of matter. Einstein's revelation showed that gravity was not just a force pulling objects together, but a sculptor of time itself, bending and stretching temporal flow around massive objects, in ways that made each region of space keep its own unique rhythm. The stronger the gravitational field, the more dramatically time was affected, creating a cosmic hierarchy where temporal flow varied with the local density of matter and energy. Near black holes, where gravitational fields reach their maximum intensity, time slowed to a crawl relative to distant observers, with clocks running thousands of times slower than they would in the emptiness of intergalactic space. An observer falling toward a black hole would experience time normally from their own perspective, while distant observers would see their clocks running increasingly slowly as they approached the event horizon. In the emptiness between galaxies, where gravitational fields were minimal, time flowed at rates that seemed almost leisurely by comparison to the compressed temporal experience near massive objects. This variation in temporal flow meant that the universe operated like a vast collection of clocks, each running at slightly different rates depending on their gravitational environment. Gravitational time dilation revealed that there was no universal now, no cosmic moment that all observers could agree upon simultaneously, but rather a symphony of temporal experiences playing at different rates throughout the universe. Each massive object created its own temporal environment, establishing local rhythms that diverged from the experiences of observers in different gravitational conditions. Massive objects created temporal valleys, where clocks ran slow compared to the surrounding space, while the peaks of space-time, regions far from gravitational sources, allowed time to flow more freely. This gravitational topography of time meant that duration itself varied across space, creating a landscape of temporal experience as varied as the distribution of matter and energy throughout the cosmos. The warping of time by mass and energy demonstrated that time was not an independent dimension existing separately from the physical universe, but intimately woven into the fabric of space itself, inseparable from the matter and energy that filled cosmic space. Time and space formed a unified medium, space-time, that served as both the stage for cosmic events and an active participant in their unfolding. Neutron stars, with their extreme density, created some of the most dramatic examples of gravitational time dilation outside of black holes. Clocks on the surface of these stellar remnants would run noticeably slower than identical clocks in Earth orbit, demonstrating that stellar evolution had created not just new chemical elements, but new temporal environments with their own characteristic rhythms. GPS satellites orbiting Earth required constant correction for both special and general relativistic time dilation effects, proving that Einstein's insights about time's flexibility were not just theoretical abstractions, but practical realities that had to be accounted for in modern technology. Gravity had revealed time's flexibility, demonstrating that duration itself could be compressed, stretched, and molded by the very phenomena it was measuring, transforming time from a passive backdrop into an active participant in the cosmic drama of matter, energy, and space-time curvature. Deep within the atomic realm, where Einstein's curved space-time met the fundamental building blocks of matter, physics encountered its strangest frontier, a quantum wonderland where the familiar rules of temporal flow broke down completely, revealing that time itself might be far more mysterious and observer-dependent than anyone had ever imagined. The microscopic world operated according to principles that seemed to mock every human intuition about cause and effect, temporal sequence, and the relationship between observation and reality. Where classical physics presented a universe of predictable clockwork, quantum mechanics revealed a realm of fundamental uncertainty, where the very act of looking at a system changed its behavior in ways that challenged the notion of objective temporal flow. Quantum mechanics unveiled time's most mysterious face, where particles could exist in multiple states simultaneously until the moment of measurement collapsed their infinite possibilities into single, definite outcomes. This wasn't simply a limitation of knowledge or measurement precision, but a fundamental feature of reality where the future remained genuinely undetermined until observation forced quantum systems to choose specific trajectories from among their many potential paths. The act of measurement seemed to create moments rather than simply record them, as if conscious observation played an active role in transforming quantum potential into classical reality. Before measurement, particles existed in temporal superposition, exploring all possible futures simultaneously like ghostly possibilities spread across multiple timelines that converged into a single reality only when witnessed by conscious observers or measuring devices. Quantum particles existed in superposition across time. simultaneously exploring multiple temporal paths until observation collapsed their possibilities into single, definite moments of experience. This temporal superposition suggested that the future was not predetermined, but remained genuinely open, with quantum systems maintaining access to multiple potential timelines until forced to choose one through the intervention of measurement. The quantum Zeno effect demonstrated something even stranger, that frequent observation could freeze the evolution of quantum systems, preventing them from changing state through the paradoxical mechanism of excessive attention. This phenomenon suggested that consciousness and time were connected in ways that transcended classical physics, where the act of watching could literally stop the flow of quantum temporal processes. Entangled particles revealed time's non-local nature through instantaneous correlations that seemed to bypass the normal flow of temporal causality. When two particles became quantum entangled, measuring one immediately determined the state of the other, regardless of the distance separating them, creating connections that Einstein famously called spooky action at a distance, but which demonstrated that quantum reality operated according to non-local temporal principles. These quantum correlations appeared to occur faster than light could travel between the particles, suggesting that quantum information might propagate through dimensions of time and space that classical physics could not access. The entangled particles seemed to share a common temporal state that transcended their spatial separation, as if they remained connected through quantum temporal channels that operated outside normal spacetime. Quantum tunneling presented another temporal mystery where particles appeared to cross energy barriers faster than light should allow, hinting at temporal shortcuts through the fabric of spacetime itself. Some experiments suggested that tunneling particles might even arrive at their destinations before classical physics predicted they should, raising questions about whether quantum processes could violate causality or access alternative temporal pathways. The measurement problem at the heart of quantum mechanics suggested that time might be fundamentally tied to consciousness and observation, raising profound questions about the relationship between mind and temporal reality. The collapse of the quantum wave function appeared to require some form of conscious witness or measurement apparatus, suggesting that time's flow from potential to actual might depend on the presence of observers. This quantum perspective on time raised the ultimate question: was time discovering conscious observers through the evolution of complex systems capable of quantum measurement, or were conscious observers creating time through the act of witnessing quantum reality and collapsing infinite possibilities into single moments of experienced existence? Among all the mysteries that quantum mechanics had revealed about time's strange behavior, perhaps the deepest puzzle remained hidden in plain sight, a question so fundamental that it touched every moment of ordinary experience, yet so profound that it challenged the very foundations of physical law and cosmic purpose. The equations that governed atomic interactions, electromagnetic forces, and even gravitational dynamics contained a curious mathematical property that had puzzled physicists for generations. These fundamental laws appeared completely symmetric with respect to time, meaning they worked equally well when run forward or backward, like movies that made perfect sense whether played normally or in reverse. If the basic rules of physics showed no preference for temporal direction, why did the universe so clearly distinguish between past and future? Why did cause always precede effect? Why did broken dishes never spontaneously reassemble? Spilled milk never flow back into containers, and memories never form about tomorrow while forgetting yesterday? The fundamental laws of physics appeared symmetric in time, yet the universe had somehow chosen a direction, creating the arrow of time that distinguishes past from future in ways that remain mysteriously irreversible despite the underlying time-symmetric nature of physical law. This asymmetry between theoretical possibility and observed reality pointed towards something profound about the relationship between microscopic reversibility and macroscopic experience. The answer emerged from the realm of thermodynamics, where the behavior of large collections of particles revealed emergent properties that were absent from the individual components. While each particle collision was perfectly reversible in principle, the collective behavior of billions of particles created statistical tendencies that favored certain directions of change over others. Entropy became time's compass, pointing toward increasing disorder and complexity as isolated systems evolved from organized states toward thermal equilibrium and maximum randomness. This wasn't a fundamental law like conservation of energy, but a statistical inevitability that emerged from the sheer number of ways that particles could arrange themselves in space and time. The second law of thermodynamics established time's preferred direction through simple probability rather than fundamental force, ensuring that broken eggs never spontaneously reassemble, and that heat always flows from hot to cold, never the reverse. The overwhelmingly vast number of disordered configurations compared to ordered ones made the spontaneous organization of complex systems statistically impossible over observable timescales. This thermodynamic arrow of time created a cosmic bias toward change and evolution, driving the universe away from its initial simple state, a smooth distribution of hydrogen and helium, toward increasing complexity and differentiation through gravitational collapse, stellar nuclear synthesis, and the formation of increasingly elaborate cosmic structures. Yet within this general trend toward maximum entropy, local pockets of organization emerged and flourished through energy flows that decreased local entropy while increasing overall cosmic disorder. Stars concentrated matter and energy while radiating heat into space. Planets formed complex geological systems, and eventually life appeared as the most sophisticated example of local entropy reduction. Life and consciousness could develop in these islands of decreasing entropy because they operated as open systems, constantly importing energy and exporting waste heat while creating internal organization that defied the local increase of entropy. Living organisms became temporary violations of the second law, maintaining their complex structures by accelerating entropy production in their environment. The emergence of life demonstrated that the arrow of time was not simply about decay and dissolution, but about the creative potential hidden within thermodynamic processes. Evolution used the flow of entropy to drive increasing biological complexity, creating organisms capable of memory, anticipation, and eventually the development of conscious awareness of temporal flow itself. The arrow of time had given the universe a sense of direction and purpose, transforming it from a static collection of particles into a dynamic system capable of growth, evolution, and the emergence of observers who could contemplate their own temporal existence while contributing to the very entropy production that made their consciousness possible. From the thermodynamic flows that had created the arrow of time emerged something unprecedented in cosmic history, matter that could organize itself into patterns complex enough to not just experience temporal flow, but to actively measure, anticipate, and synchronize with the rhythmic cycles that govern both terrestrial and cosmic existence. The emergence of life marked a revolutionary transformation in the relationship between matter and time. Where stars had created reliable external chronometers through nuclear fusion, and atoms had provided quantum temporal standards through their energy transitions, living organisms developed something entirely new: internal biological clocks that could track time independently while remaining synchronized with external cosmic rhythms. Life discovered how to internalize time, developing circadian rhythms and biological clocks that synchronized living organisms with the cosmic cycles of day and night, seasons and years, through molecular mechanisms that operated with precision rivaling any atomic clock. These weren't simply passive responses to environmental changes, but active temporal prediction systems that enabled organisms to anticipate cyclical events before they occurred. The biological internalization of time began at the cellular level, where evolution crafted molecular chronometers that could measure intervals with remarkable precision across timescales ranging from microseconds to decades. Cells evolved protein oscillators that could track circadian cycles, metabolic rhythms that coordinated chemical reactions across cellular compartments, and genetic regulatory networks that controlled the timing of development and reproduction. Cells evolved molecular chronometers that could measure intervals with remarkable precision, from the rapid oscillations of metabolic processes that coordinated energy production and consumption within milliseconds, to the long cycles of growth, reproduction, and aging that unfolded across entire lifetimes. Each cellular process was temporally choreographed to maximize efficiency and survival in changing environmental conditions. DNA replication became a temporal process where genetic information was copied with clockwork precision, each cell division marking another tick in the biological clock that measured generational time. The faithful copying of genetic material required exquisite temporal coordination between hundreds of molecular machines, all working in synchronized harmony to ensure that cellular division occurred at precisely the right moment in the cell cycle. The development of multicellular organisms introduced new layers of temporal complexity, where individual cellular clocks had to be coordinated across entire organ systems. Circadian master clocks in animal brains evolved to synchronize billions of cellular timepieces, creating organism-wide temporal coordination that enabled complex behaviors like sleep-wake cycles, seasonal reproduction, and migration timing. Evolutionary time emerged as species changed across millions of years, with natural selection operating as a vast temporal filter that preserved beneficial adaptations while discarding less successful variations over timescales that dwarfed individual lifetimes. This created a hierarchy of biological time from molecular oscillations to evolutionary epochs, with each level influencing and being influenced by the others. Migration patterns linked biological time to astronomical cycles in remarkable demonstrations of temporal precision as creatures learned to navigate using celestial timepieces and seasonal rhythms that connected their life cycles to cosmic periodicities. Birds, sea turtles, and countless other species developed internal navigation systems that could track both their spatial location and temporal position within annual cycles. The evolution of biological memory systems enabled organisms to carry temporal information across individual lifetimes, creating cultural transmission mechanisms where learned temporal patterns could be passed between generations. This allowed species to accumulate temporal knowledge about environmental cycles, predator behavior, and resource availability across timescales longer than any individual could experience. Through biological evolution, time became not just a dimension of physics, but a creative force that shaped the development of complexity, consciousness, and the capacity for temporal awareness itself. Living organisms had transformed from passive subjects of temporal flow into active participants who could measure, predict, and even manipulate their temporal environment. Life had internalized time's flow and learned to dance with its rhythms, creating the biological foundation for the emergence of consciousness, the next great innovation in the universe's evolving relationship with temporal existence, where awareness itself would become time's most sophisticated witness and creative partner. Within the intricate biological clockwork that life had evolved to synchronize with cosmic rhythms, a new form of temporal experience was about to emerge, one that would transform time from an objective physical dimension into a subjective, psychological reality experienced from within, creating the foundation for scientific inquiry, artistic expression, and philosophical contemplation of temporal existence itself. The development of nervous systems marked a revolutionary leap in the universe's relationship with time. Where previous biological clocks had operated automatically through molecular and cellular mechanisms, neural networks introduced something unprecedented, the capacity for flexible temporal processing that could adapt, learn, and create entirely new relationships with duration, sequence, and temporal experience. Simple neural networks began as basic pattern detectors that could recognize temporal sequences in sensory input, distinguishing between the rhythmic approach of a predator and the irregular movements of wind-blown vegetation. These early temporal processing abilities provided survival advantages that drove the evolution of increasingly sophisticated neural architectures capable of more complex temporal analysis and prediction. With the emergence of nervous systems and brains, time gained its first conscious witnesses, organisms capable of experiencing duration, memory, and anticipation in ways that transform time from a purely physical dimension into a psychological reality that could be subjectively experienced, mentally manipulated, and consciously contemplated. Neurons developed the remarkable ability to process temporal sequences with extraordinary precision, recognizing patterns across time, and creating the neurological foundation for experiences of rhythm, melody, and narrative sequence that would eventually enable music, storytelling, and the temporal arts that distinguish conscious culture from automatic biological responses. The neural processing of temporal information occurred through sophisticated mechanisms that could detect, store, and compare temporal patterns across multiple timescales simultaneously. Networks of neurons learned to fire in specific sequences that encoded the timing of past events while generating predictions about future occurrences, creating the neural basis for temporal cognition. Memory systems allowed conscious beings to carry the past into the present in ways that transcended simple biological programming, creating personal histories that could be accessed, reviewed, and integrated with new experiences. This temporal storage capacity enabled learning from past mistakes, building upon previous successes, and developing increasingly sophisticated behavioral strategies based on accumulated temporal experience. Imagination enabled conscious beings to project possible futures through mental simulation, creating the subjective experience of temporal travel through consciousness that allowed organisms to explore potential scenarios before committing to specific actions. This capacity for temporal projection became the foundation for planning, creativity, and the development of culture based on shared visions of possible futures. Different neural processes operated on dramatically different timescales, creating a temporal hierarchy within conscious experience. Reflexes operated on millisecond timescales, enabling rapid responses to immediate threats, while slower rhythms of learning and habit formation could persist across entire lifetimes, creating the long-term behavioral adaptations that defined individual personality and cultural transmission. The brain became a temporal orchestra where multiple clocks ran simultaneously, coordinating everything from the rapid oscillations of heartbeat and breathing to the slower rhythms of circadian cycles and seasonal awareness. This neural temporal coordination required sophisticated synchronization mechanisms that could maintain coherent conscious experience despite the vastly different timescales of various biological and mental processes. Emotional systems added effective coloring to temporal experience, making some moments feel precious and others feel burdensome, creating the subjective sense that time could drag slowly during boredom or fly quickly during enjoyment. These emotional temporal modulations became central to conscious experience, influencing memory formation, decision-making, and the overall quality of temporal awareness. Consciousness had transformed time from an external dimension measured by atomic clocks and stellar cycles into an internal experience that could be subjectively modulated, creating the temporal foundation for art, science, and philosophy. The subjective flow of temporal awareness would eventually enable conscious beings to study, measure, and contemplate the nature of time itself through scientific investigation and philosophical reflection, completing the circle from cosmic time to conscious temporal experience. The conscious minds that had learned to experience time subjectively through neural temporal processing were about to embark on humanity's most ambitious project: the precise measurement and artificial division of duration into units so exact they would eventually surpass the natural chronometers that had governed life for billions of years. Early human societies lived within the natural temporal rhythms established by astronomical cycles, waking with sunrise and settling into rest with sunset, following seasonal patterns of activity that synchronized human culture with the cosmic clockwork of planetary rotation and orbital mechanics. These natural rhythms provided adequate temporal coordination for small communities where everyone could observe the same sky and respond to the same environmental cues. As human civilizations grew larger and more complex, the need for precise temporal coordination became essential for activities that extended beyond immediate visual contact. Trade expeditions required synchronized departures and arrivals. Agricultural communities needed coordinated planting and harvesting schedules, and religious observances demanded precise timing that could unite scattered populations in common temporal experience. Human consciousness brought unprecedented precision to timekeeping as civilizations learned to divide the day into hours, minutes, and seconds, creating artificial temporal structures that gradually superseded the natural rhythms that had governed biological existence since life began. This temporal standardization represented humanity's first step toward technological mastery over natural processes. The earliest timekeeping devices worked by harnessing natural processes that operated with predictable regularity. Sundials tracked the shadow cast by solar motion, water clocks measured duration through controlled fluid flow, and candle clocks burned at steady rates that could mark the passage of hours during periods when celestial observations were impossible due to weather or indoor activities. Sundials and water clocks gave way to mechanical timepieces that could measure duration with increasing accuracy through ingenious mechanical systems that converted the regular oscillation of pendulums or springs into precise temporal measurements. These mechanical chronometers allowed human activities to be coordinated across larger and larger scales of social organization, enabling the complex logistics that supported growing cities and expanding trade networks. The invention of precise chronometry enabled revolutionary advances in navigation across oceans, as accurate timepieces allowed sailors to determine longitude through careful comparison of local solar time with the time at a known reference location. This temporal navigation technology opened the world to exploration and trade on scales that transformed human civilization from isolated regional cultures into a globally connected species. Industrial development demanded ever more precise temporal coordination as manufacturing processes required synchronized operations across multiple workers and machines. Factory whistles, standardized work schedules, and coordinated transportation systems all depended on precise timekeeping that could synchronize human activity with mechanical processes operating at scales and speeds that exceeded natural biological rhythms. The development of telegraph and telephone communications created the need for time zone standardization, as messages could now travel faster than the sun's apparent motion across Earth's surface. This led to the artificial division of the planet into time zones that reflected political and economic boundaries rather than natural astronomical relationships, creating human temporal territories that superseded cosmic chronometry. Human time became increasingly detached from natural cycles as artificial lighting extended productive hours beyond sunset and climate control systems freed human activity from seasonal constraints. Electric lights, heated buildings, and mechanical transportation allowed human societies to operate according to artificial temporal schedules that ignored the natural rhythms that had governed all previous life. The development of atomic clocks achieved temporal precision that exceeded anything in nature, measuring time in terms of quantum transitions that could detect variations in duration smaller than the natural fluctuations of atomic processes themselves. These quantum chronometers enabled technologies like GPS navigation and international financial transactions that required temporal precision measured in billionths of seconds. Through technology, humans had become the most precise timekeepers in the known universe, yet this mastery of measurement only deepened the mystery of what time actually was and why conscious beings felt such a profound need to quantify its passage with ever-increasing precision and artificial complexity. Just as humanity achieved unprecedented mastery over temporal measurement through atomic precision, a revolutionary insight was about to shatter every assumption about the nature of time itself, a discovery so profound it would transform time from humanity's most carefully measured quantity into its most mysterious and malleable dimension. For centuries, scientists had operated under the intuitive assumption that time flowed uniformly throughout the universe, providing an absolute temporal framework that all observers could agree upon regardless of their location or motion. This classical view treated time as the universal stage upon which all events occurred, flowing steadily from past to future at the same rate everywhere in the cosmos. The precision of atomic clocks and the accuracy of celestial mechanics seemed to confirm this absolute view of time, with synchronized chronometers maintaining their coordination across vast distances and astronomical observations revealing predictable periodicities that suggested universal temporal constancy. The success of Newtonian physics in describing planetary motion reinforced the belief that time was indeed the fixed backdrop against which all physical processes unfolded. Albert Einstein's revolutionary insights began with a simple but profound observation about the nature of light and motion that would ultimately transform humanity's understanding of temporal reality. The constancy of light speed for all observers, regardless of their motion, implied that space and time could not be absolute and independent, but must be relative and interconnected in ways that classical physics had never imagined. The special and general theories of relativity revolutionized humanity's understanding of time by revealing that duration was not absolute but relative to motion and gravity, fundamentally altering the conception of temporal reality from a universal constant to a dynamic dimension that responded to physical conditions and observer motion. Time dilation emerged as one of the most startling predictions of special relativity, showing that moving clocks ran slower compared to stationary ones from the perspective of external observers. This wasn't a mechanical effect of motion on clock mechanisms, but a fundamental property of time itself. Duration literally stretched for objects in motion relative to any given observer. Gravitational time dilation, predicted by general relativity, demonstrated that clocks ran slower in stronger gravitational fields, proving that time was malleable rather than fixed, and that massive objects could literally slow the passage of duration in their vicinity. This gravitational effect on time showed that the presence of matter and energy could warp temporal flow just as it curved spatial geometry. The twin paradox illustrated the practical implications of relativistic time dilation through the hypothetical scenario of space travel at high speeds. One twin traveling at near-light velocity would experience time normally from their own perspective, while aging significantly slower than their Earthbound sibling, demonstrating that differential aging could result from relative motion through space-time. Simultaneity became relative under Einstein's framework, meaning that events that appeared simultaneous to one observer might occur at different times for another observer moving at a different velocity. This relativity of simultaneity showed that there was no universal now that all observers could agree upon, fundamentally challenging intuitive notions of temporal coordination. The merger of space and time into space-time revealed these dimensions as inseparable aspects of a four-dimensional continuum where temporal and spatial coordinates were interchangeable under certain mathematical transformations called Lorentz transformations. This space-time unification showed that the familiar separation between space and time was an artifact of limited human experience rather than a fundamental feature of reality. Einstein's insights revealed that time was not the universal backdrop against which events occurred, but an active participant in the structure of reality itself. Time proved to be as flexible and dynamic as the space through which matter and energy moved, capable of stretching, compressing, and curving in response to motion and gravitational fields. The implications were staggering. Time was not humanity's most precisely measured dimension, but its most mysteriously variable one, challenging every assumption about temporal constancy, while opening new questions about the fundamental nature of existence, causality, and the relationship between consciousness and cosmic reality. Einstein's revelation that time was relative rather than absolute opened a philosophical chasm that challenged the deepest human intuitions about existence, the nature of consciousness, and the nature of reality itself, leading to a conception of temporal existence so radical that it transformed the entire meaning of past, present, future, and the experience of being alive in a particular moment. The mathematical framework of relativity, with its four-dimensional space-time continuum, suggested something profound and unsettling about the nature of temporal existence. If space and time were unified into a single geometric structure, and if simultaneity was relative to observers, then perhaps the familiar experience of flowing time was not a fundamental feature of reality, but a peculiar artifact of conscious perception. This line of reasoning led physicists and philosophers to contemplate the block universe, a conception of reality where all moments in cosmic history, from the Big Bang to the far future, exist simultaneously in an eternal four-dimensional structure that contains the entirety of temporal existence. In this view, time does not flow like a river, but exists all at once like a vast landscape that conscious beings traverse moment by moment. Einstein's space-time led to the conception of the block universe, where all moments, past, present, and future, exist simultaneously in a four-dimensional structure that contained the entirety of cosmic history spread out across temporal dimensions, just as spatial locations are spread across geographical dimensions. Every event that had ever occurred, or would ever occur, was equally real and permanent within this eternal block. From this eternal perspective, the flow of time was revealed as a subjective experience rather than an objective feature of reality, with conscious observers creating the illusion of temporal passage as they move through their world lines in space-time. Just as a train passenger experiences motion through a landscape that exists entirely independent of their journey, conscious beings might experience temporal flow through a space-time that exists entirely independent of their passage through it. The block universe suggested that the future was as real and determinate as the past, existing eternally in the space-time continuum, even though conscious beings could only access one temporal moment at a time due to the limitations of their neural processing systems. This meant that future events were not possibilities waiting to be actualized, but concrete realities that conscious observers had simply not yet encountered in their journey through space-time. This perspective challenged fundamental human intuitions about free will and the openness of the future, suggesting that all choices and events were equally real and permanent features of the space-time block. If the future already existed, in the same sense that distant spatial locations existed, then perhaps human agency was illusory and all decisions were predetermined by the eternal structure of space-time itself. The growing block theory offered a philosophical compromise between the eternal block and human temporal experience, proposing that the past and present were real as fixed features of space-time, while the future remained genuinely open, with new moments being continuously added to the block as time advanced. This dynamic view preserved some sense of temporal becoming while acknowledging the reality of past events. Presentism provided another alternative, suggesting that only the present moment was real, with the past having ceased to exist and the future not yet having come into being. This view aligned more closely with human temporal experience, but struggled to accommodate the relativistic insight that simultaneity was observer-dependent, making it difficult to define a universal present moment. These different interpretations of time's reality raised fundamental questions about the nature of existence, consciousness, and the relationship between subjective experience and objective physical reality. Did conscious experience create temporal flow, or did temporal flow create the conditions for conscious experience? Was the sense of free will an emergent property of complex information processing, or a genuine causal force in space-time? The block universe demonstrated that time remained one of the deepest mysteries in physics and philosophy, where Einstein's mathematical insights had solved certain technical problems while opening profound questions about the nature of existence, causality, and the meaning of conscious temporal experience in a possibly eternal and predetermined cosmos. While physicists debated whether time was an eternal block or a flowing river, neuroscientists were making discoveries that would challenge the very foundation of temporal experience, revealing that the most intimate and seemingly obvious aspect of existence, the feeling of time passing, might be nothing more than an elaborate construction created by neural processes that could be manipulated, distorted, and even completely abolished. The scientific investigation of consciousness had begun to reveal that many aspects of human experience that seem most fundamental and unquestionable were actually sophisticated neural constructions. Color, for instance, existed not in the external world, but in the brain's interpretation of electromagnetic wavelengths, while the sense of a unified self emerged from the integration of multiple neural processes rather than reflecting any single unified entity. These discoveries raised a profound question about temporal experience. If color and selfhood were neural constructions rather than direct perceptions of reality, might time itself be another elaborate illusion created by the brain's information processing systems rather than a direct experience of external temporal flow? Modern neuroscience revealed that the human experience of time was indeed constructed by the brain through complex neural processes that could be altered, distorted, and even completely disrupted, suggesting that temporal flow might be more illusion than reality. The subjective sense of duration, sequence, and temporal passage appeared to emerge from a neural computation rather than direct temporal perception. The brain's temporal processing systems created the sense of duration, sequence, and simultaneity through the integration of multiple neural clocks that operated on different timescales, from the millisecond oscillations of neural firing patterns to the circadian rhythms that tracked daily cycles, to the slower processes of memory formation that operated across years and decades. These neural chronometers were not passive recording devices, but active construction systems that assembled temporal experience from disparate pieces of neural information. The sense of temporal flow emerged from the brain's integration of memory traces, sensory inputs, attention patterns, and predictive models rather than from any single temporal sensing mechanism. Experiments with brain stimulation, psychoactive substances, and meditation showed that the subjective experience of time could be dramatically altered through changes in neural chemistry and electrical activity. Deep brain stimulation could make seconds feel like minutes, while certain psychedelic compounds could create experiences where hours passed in what seemed like moments or minutes stretched into subjective eternities. Meditation practitioners reported states of consciousness where temporal flow seemed to slow dramatically or disappear entirely, suggesting that the ordinary experience of time passing was dependent on specific patterns of neural activity that could be modified through mental training. These altered states revealed that temporal experience was far more plastic and malleable than ordinary consciousness suggested. Patients with certain types of brain damage lost the ability to experience temporal sequence or duration, yet continued to function in a present-focused existence that revealed time's constructed nature. Some could no longer form new memories, living in an eternal now where each moment seemed fresh and unprecedented, while others lost the ability to sequence events, experiencing life as a series of disconnected temporal fragments. Neurological studies revealed that the brain actively created the sense of temporal unity that bound experiences together into coherent sequences, rather than simply recording objective temporal relationships. The binding of different sensory inputs into unified temporal experiences required active neural coordination that could be disrupted by brain injury or altered by neurochemical changes. The rubber hand illusion and similar experiments demonstrated that the brain's temporal binding mechanisms could be fooled, creating false senses of temporal simultaneity or sequence that revealed the constructed nature of temporal experience. These illusions showed that temporal perception was subject to the same constructive processes that created other aspects of conscious experience. Studies of flow states, where people became so absorbed in activities that they lost track of time entirely, suggested that the sense of temporal passage might emerge from the brain's monitoring of its own processes rather than from direct perception of external temporal flow. When attention became completely absorbed in present moment activity, the neural mechanisms that created temporal awareness seemed to shut down, resulting in timeless experience despite the continued passage of objective time. What if the universe itself were writing its autobiography, inscribing every moment of its 13.8 billion-year story into the very fabric of space and time? Every spinning neutron star, every expanding galaxy, every decaying atom becomes a page in this cosmic journal, recording time with precision that would make our finest clockmakers weep with envy. Across the infinite expanse of space, nature has crafted the most extraordinary timekeeping devices imaginable. These aren't the mechanical marvels of human engineering, but living calendars born from the fundamental forces that shape reality itself. Each one tells a different chapter of the universe's grand narrative, measuring time on scales that dwarf human comprehension, yet remain intimately connected to our own existence. Deep in the remnants of collapsed stars, pulsars spin with such unwavering precision that they rival the atomic clocks buried in physics laboratories on Earth. These neutron stars, compressed to densities beyond imagination, rotate hundreds of times per second while beaming lighthouse sweeps of radiation across the cosmos. Their pulses arrive at Earth with clockwork regularity, creating temporal beacons that astronomers can detect from distances spanning millions of light years. The stability of these cosmic chronometers astounds even seasoned scientists. A pulsar's rotation period remains constant to within 1 part in 100 million, making it more reliable than any timepiece humanity has ever constructed. As these stellar lighthouses sweep their beams across space, they create a network of natural GPS satellites, allowing us to navigate not just through space but through time itself. Woven throughout the cosmos lies perhaps the most ancient timekeeper of all, the cosmic microwave background radiation. This faint afterglow of the Big Bang carries within it the timestamp of creation itself, a fossil record of the universe when it was merely 380,000 years old. Scientists can read this primordial light, like archaeologists studying ancient artifacts, measuring temperature fluctuations that reveal how matter first began to clump together into the seeds of galaxies. This cosmic background radiation provides us with the universe's birth certificate, allowing us to calculate its age with startling precision. Every photon of this ancient light has been traveling toward us for over 13 billion years, stretched and cooled by the expansion of space itself. When we observe this radiation, we're literally seeing the universe as it appeared when it first became transparent to light, witnessing the moment when cosmic dawn broke across the expanding void. But the universe's autobiography extends far beyond these electromagnetic whispers. Every time we peer through a telescope at distant galaxies, we're reading pages from cosmic history written in starlight. The light from these remote islands of stars began its journey billions of years ago, carrying with it a snapshot of how the universe appeared in its youth. We see these galaxies not as they are now, but as they were when their light first started racing toward Earth across the cosmic void. This creates a remarkable phenomenon. The deeper we look into space, the further back in time we travel. Galaxies billions of light years away appear to us as they existed when the universe was young and wild, filled with actively forming stars and colliding galactic neighbors. Through this natural time machine, astronomers can trace the universe's evolution from its chaotic infancy to the more structured cosmos we observe nearby. Meanwhile, within the atoms that compose our own bodies and the rocks beneath our feet, radioactive elements continue their patient countdown. These natural clocks tick away at rates determined by the fundamental forces of physics, providing timestamps for everything from the formation of Earth to the age of meteorites that crash through our atmosphere. Uranium decays into lead, potassium transforms into argon, and carbon-14 gradually disappears, each process following mathematical laws as reliable as the motion of planets. These radioactive chronometers reveal that time is woven into the very structure of matter itself. The elements forged in the nuclear furnaces of ancient stars carry within them the memory of their creation, allowing us to date rocks billions of years old and trace the history of our planet back to its violent birth in a disk of cosmic debris. Perhaps most remarkably, all these cosmic calendars tell the same fundamental story. Whether we're measuring the expansion of space through distant supernovae, dating meteorites through radioactive decay, or analyzing the cosmic microwave background, every technique converges on the same conclusion. Our universe is approximately 13.8 billion years old, born in a moment of incredible heat and density that we call the Big Bang. This convergence of evidence represents one of science's greatest triumphs, demonstrating that time is not merely a human construct, but a fundamental feature of reality itself. From the quantum-scale vibrations of atomic clocks to the billion-year rotation of galaxies, time flows through every corner of the cosmos, creating a universal symphony of temporal rhythms that connects the smallest particles to the largest structures in existence. As we drift through our own brief moment in this cosmic timeline, we carry within us the atoms forged in stellar cores, the calcium in our bones dated by radioactive decay, and the iron in our blood bearing the timestamp of ancient supernovae. We are not separate from these cosmic calendars. We are part of them, living pages in the universe's ongoing autobiography, temporary arrangements of matter and energy that will someday return to the cosmic story that birthed us. Can you feel the lightning storm happening inside your skull right now? At this very moment, as you listen to these words, billions of electrical signals are racing through networks more complex than any city, creating the mysterious phenomenon we call consciousness from nothing more than chemistry and time. Within the 3-pound universe nestled between your temples, a temporal symphony plays at speeds that would make quantum particles envious, yet remain slow enough for the delicate dance of awareness to unfold. This is where the cosmic story of time takes its most intimate turn, where the abstract rhythms of physics transform into the beating heart of subjective experience. Every thought you've ever had began as a spark of electricity traveling down the length of a neuron at precisely 120 meters per second. Not the instantaneous flash of light, nor the glacial drift of continental plates, but a speed perfectly calibrated for consciousness to emerge from the storm of neural activity. This electrical cascade, called an action potential, represents one of evolution's most elegant solutions to the problem of time itself. As these bioelectric signals race along your neural pathways, they encounter synapses, the microscopic gaps between neurons where electricity transforms into chemistry. Here, in spaces so small that millions could fit on the head of a pin, neurotransmitter molecules drift across the void like molecular messengers carrying temporal secrets. This synaptic transmission takes mere milliseconds, yet within those brief moments lies the foundation of every memory you've ever formed and every emotion you've ever felt. The brain orchestrates this neural ballet across multiple temporal frequencies, creating layers of consciousness that operate like instruments in a vast orchestra. Fast gamma waves, oscillating 30 to 100 times per second, bind together the separate streams of sight, sound, and sensation into the unified experience of the present moment. When you recognize a face in a crowd or solve a complex problem, these high-frequency rhythms synchronize across distant brain regions, creating the neural basis of focused awareness. Beneath this rapid chatter flow slower, deeper currents of neural activity. Alpha waves sweep across the brain 8 to 12 times per second during relaxed wakefulness, while the even slower delta rhythms of deep sleep cycle just once every few seconds, allowing the brain to consolidate memories and repair itself during the unconscious hours. These different frequencies create what neuroscientists call the temporal hierarchy of consciousness, a multi-layered architecture of awareness, where each level operates on its own timescale. But perhaps most remarkable is how the brain creates the illusion of a continuous present from discrete moments of neural processing. Your visual system updates its picture of the world roughly 60 times per second, yet you experience vision as a smooth, uninterrupted stream. This temporal binding requires exquisite timing. Sensory inputs arriving just milliseconds apart can be woven together into a single perceptual experience, while those arriving further apart remain forever separate in your consciousness. Memory formation reveals time's most crucial role in shaping who you are. For an experience to transition from fleeting awareness to lasting memory, specific temporal windows must align with molecular precision. Proteins must be synthesized, synaptic connections must be strengthened, and neural pathways must be reinforced, all according to biological timetables measured in minutes and hours, rather than the milliseconds of thought itself. This process explains why some moments etch themselves permanently into memory while others fade like morning mist. The emotional intensity of an experience, mediated by stress hormones and neuromodulators, can either extend these critical time windows, allowing memories to form with crystal clarity, or disrupt them entirely, creating the blank spaces that sometimes follow traumatic events. Learning, too, follows its own temporal logic. The brain's plasticity, its ability to rewire itself based on experience, operates within specific time constraints that evolution has refined over millions of years. Practice a skill repeatedly within the right temporal intervals, and neural pathways strengthen and accelerate. Miss these critical windows and the opportunity for optimal learning may pass, locked away by the brain's own biological clock. Perhaps most mysteriously, consciousness itself seems to bend and shape the subjective experience of time. During moments of intense fear or excitement, the brain's heightened state of arousal creates more detailed memories, making these experiences seem to last longer in retrospect. Meanwhile, the flow state achieved by artists and athletes involves a dissolution of temporal awareness, where hours can pass like minutes, while the conscious mind merges seamlessly with the task at hand. The speed of thought thus becomes a bridge between two worlds, the objective realm of physics and chemistry, where time flows uniformly and measurably, and the subjective realm of consciousness, where time stretches and contracts according to the rhythms of awareness. In your brain, the universe's 13th 8-billion-year journey toward complexity reaches a crescendo, creating from simple electrical impulses the rich temporal tapestry of human experience. As you process these very words, your neural networks are performing a feat that would astound the ancient astronomers who first pondered time's mysteries. You are not merely experiencing the passage of time, you are actively constructing it, moment by moment, thought by thought, creating from the lightning storms of neural activity the flowing stream of consciousness that carries you through each day. In this biological theatre, time reveals its most profound secret. It is not just the stage upon which consciousness performs, but consciousness itself, emerging from the precise temporal choreography of billions of neurons firing in the darkness behind your eyes, transforming the universe's story into the intimate narrative of your own awareness. What if you could step outside the prison of the present moment and walk freely through the corridors of time itself? Deep within the architecture of your mind lies a palace more vast than any structure ever built, a realm where yesterday, tomorrow, and worlds that never were coexist in chambers of neural possibility. This is the memory palace of consciousness, where linear time surrenders to the sovereign power of the human mind. Here, in networks of neurons firing across the temporal lobes, memory has accomplished something that physics declares impossible. It has created genuine time travel, allowing you to exist simultaneously in multiple moments across the span of your life. Every memory begins its journey in the hippocampus, that seahorse-shaped structure nestled deep within your brain's temporal regions. Like a master librarian, it sorts through the constant flood of sensory experience, deciding which moments deserve preservation and which will fade into the forgotten void. But this is no passive recording device. The hippocampus actively constructs memories through a delicate dance of neural timing that unfolds across seconds, hours, and even decades. The formation of a single memory requires an intricate temporal choreography. Within seconds of an experience, fragile electrical patterns begin forming connections between neurons. Over the following hours, these patterns strengthen through molecular processes that synthesize new proteins and reshape synaptic connections. Days and weeks later, these memories gradually migrate from the hippocampus to the brain's cortical regions, where they become woven into the broader tapestry of long-term knowledge. But the true magic begins when you retrieve these stored moments from their neural vaults. Close your eyes and remember your childhood bedroom, the face of a lost love, or the taste of your grandmother's cooking. In that instant, you have achieved something more remarkable than any feat of engineering. You have travelled backward through time, not in body but in consciousness, experiencing anew the sights, sounds, and emotions of moments that exist only in the palace of memory. This is episodic memory, the crown jewel of human consciousness, allowing you to mentally step into the shoes of your past self and experience history from within. Unlike the abstract knowledge stored in semantic memory, episodic memories carry with them the full sensory and emotional texture of lived experience. The smell of autumn leaves can instantly transport you to a specific October afternoon decades past, complete with the feeling of wind on your skin and the sound of footsteps on a forgotten path. Yet memory's relationship with time proves far more complex than simple replay. Each time you access a memory, your brain doesn't merely retrieve a static recording, it actively reconstructs the experience using a mixture of stored information, present knowledge, and future expectations. Like a master storyteller retelling an ancient tale, memory weaves together fragments of the past with threads borrowed from the present, creating narratives that feel utterly authentic while being constantly rewritten. This reconstructive nature of memory means that your past is not fixed, but fluid, continuously reshaped by who you are becoming. The child who felt terror at a thunderstorm might remember that same event differently as a weather-wise adult, with the adult's knowledge subtly colouring the childhood memory. In this way, memory creates a temporal dialogue between different versions of yourself, allowing past and present to inform each other across the years. But memory's temporal reach extends far beyond the boundaries of individual experience. Through language, stories, and cultural traditions, human consciousness has learned to share its temporal palaces, creating collective memories that span generations. The myths of ancient civilizations, the accumulated wisdom of scientific traditions, and the shared narratives that bind communities together all represent extensions of memory's power to transcend the limitations of individual lifespans. These cultural memories create temporal bridges across centuries and millennia, allowing you to carry within your mind the experiences and insights of countless ancestors. When you read the words of philosophers who died long before your birth, or when you feel moved by music composed in distant centuries, you are accessing a vast collective memory palace where the accumulated consciousness of our species continues to live and grow. Memory also serves as the foundation for mental time travel into the future. Your ability to imagine tomorrow's possibilities springs directly from your capacity to recombine and project memories of yesterday's experiences. Planning, hoping, and dreaming all depend on memory's power to transcend temporal boundaries, allowing consciousness to inhabit potential futures with the same vividness it brings to recreating the past. In this way, memory has granted human consciousness a form of temporal omnipresence, the ability to exist not just in the narrow slice of now, but across the entire span of remembered experience and imagined possibility. While your physical body remains anchored in the present moment, your consciousness roams freely through the palace of memory, gathering insights from the past and rehearsing possibilities for the future. This temporal freedom represents one of consciousness's greatest achievements. In a universe governed by the arrow of time, where entropy increases and moments pass irreversibly into history, memory has created internal dimensions where time becomes navigable, where the past remains alive and accessible, and where the future takes shape in the crucible of imagination. As you drift through the chambers of your own memory palace, you carry with you not just the record of your personal journey through time, but the accumulated temporal wealth of every conscious being who has ever wondered, remembered, and dreamed. In the end, memory reveals that consciousness itself is time's most magnificent creation, a way for the universe to step outside the flow of moments and experience the profound gift of existing across all the times that ever were and all the times that might yet be. What if the future were already reaching backward through time, casting its shadow across the present moment and guiding your every decision? Right now, as you listen to these words, your brain is performing an act of temporal sorcery that would astound the ancient oracles. It is living simultaneously in what is and what might be, shaping the present through visions of tomorrows that do not yet exist. This is the shadow of the future, a phantom presence that haunts every moment of conscious experience. Unlike memory's journey into the past, this temporal projection ventures into the realm of pure possibility, where imagination meets mathematics and hope dances with probability across the canvas of time yet to come. Deep within the neural networks of your prefrontal cortex, millions of neurons are constantly engaged in one of consciousness's most sophisticated activities, predictive processing. Every few milliseconds, your brain generates thousands of micro-predictions about what will happen next. Will the next word in this sentence make sense? Where will your hand be in half a second? What sound will emerge when you take your next breath? These predictions flow like an invisible river beneath the surface of awareness, allowing you to navigate a world in constant flux. This predictive machinery operates on timescales that span from the immediate future, anticipating the bounce of a ball or the end of a musical phrase, to the distant horizon of decades ahead. When you choose a career path, invest in retirement savings, or plant a tree you'll never see reach maturity, you are living proof of consciousness's remarkable ability to inhabit temporal spaces that exist only in potential. The development of language transformed this individual capacity for future thinking into a collective superpower. Through words, humans learned to share their temporal projections, creating shared visions of possible futures that could coordinate the actions of entire communities. When ancient farmers planned their seasonal plantings based on anticipated weather patterns, or when civilizations built structures designed to last for centuries, they were participating in a form of temporal collaboration that transcended the boundaries of individual lifespans. These linguistic bridges to the future enabled something unprecedented in the history of life on Earth, the ability to prepare for challenges that had never before occurred. Humans could imagine droughts, floods, invasions, and famines that existed only as possibilities, then take concrete actions in the present to mitigate these phantom threats. In doing so, consciousness had achieved a form of temporal paradox, allowing future events that might never happen to reshape the present moment in ways that often prevented them from occurring. Science extended this predictive reach into realms that dwarf human intuition. Through mathematical models that encode the deep regularities underlying natural processes, scientists learned to peer into the future with extraordinary precision. Weather forecasters can predict storm systems days in advance by modeling the complex interactions of atmospheric pressure, temperature, and humidity across vast regions. Astronomers calculate the positions of planets centuries into the future and trace the evolutionary paths of stars across billions of years. Yet these temporal projections also revealed the fundamental limits of predictability that govern our universe. Chaos theory demonstrated that even deterministic systems could become utterly unpredictable over time, as tiny uncertainties amplified into vast differences in outcome. The famous butterfly effect showed that a small change in initial conditions, the flapping of wings in one part of the world, could theoretically trigger a hurricane on the opposite side of the planet weeks later. Quantum mechanics added another layer of uncertainty to the future's shadow, revealing that at the most fundamental level, reality itself exists in a state of probability rather than certainty. The future, it seems, does not exist as a fixed destination awaiting discovery, but rather as a branching landscape of possibilities that collapse into actuality only through the act of observation and measurement. Despite these limits, or perhaps because of them, consciousness has developed an intricate relationship with uncertainty that shapes every aspect of human experience. We make decisions not based on perfect knowledge of future outcomes, but through a complex calculus that weighs probabilities, considers multiple scenarios, and often relies on intuitive leaps across gaps in our understanding. This dance between prediction and uncertainty creates feedback loops that blur the boundary between present and future in fascinating ways. When economists predict market crashes, their predictions can trigger the very crashes they foresaw. When scientists warn of climate change, their warnings can inspire actions that alter the climate's future trajectory. The future's shadow, it turns out, has the power to reshape the very present from which it emerges. Perhaps most remarkably, consciousness has learned to find meaning and purpose not just in what is, but in what might be. Hope, ambition, worry, and planning all depend on our ability to inhabit these temporal shadows, to experience as real the possibilities that shimmer just beyond the edge of the present moment. We suffer from anticipated losses that may never occur, and find joy in imagined achievements that exist only in potential. In this way, the future's shadow reveals one of consciousness's most profound achievements, the transformation of time from a river that carries us along into a landscape through which we can deliberately navigate. Through prediction and planning, human consciousness has learned to bend the arc of temporal development, using visions of possible futures to guide present actions toward desired outcomes. As you consider your own relationship with tomorrow's possibilities, you participate in this ancient dialogue between what is and what might be. Every decision you make, every plan you form, every dream you nurture exists at the intersection of prediction and possibility, where the future's shadow meets the present moment, and consciousness reveals its power to inhabit not just the time that is, but all the times that might yet be. Humanity has accidentally created a new species of time itself, artificial temporal environments that operate according to rules no biological clock has ever known. In the space between your computer's circuits, a different kind of time flows, where silicon thoughts race at speeds that make neural lightning seem glacial, and where the very nature of past, present, and future has been rewritten by the language of code. This is digital time, a realm where consciousness has learned to extend itself beyond the boundaries of biology into electronic domains that pulse with their own temporal heartbeats. Here, in the microscopic pathways of processors and the global networks that span continents, humanity has created artificial temporal ecosystems that challenge everything we thought we understood about the nature of duration and sequence. At the heart of this digital revolution lies the computer processor, a silicon oracle that performs billions of calculations in the time it takes your neurons to fire a single impulse. While your brain processes information at roughly 120 meters per second, electrons flow through semiconductor pathways at nearly the speed of light, creating artificial minds that experience each second as an eternity of computational possibility. This vast difference in temporal scale has given birth to artificial intelligence systems that inhabit radically different temporal landscapes than their biological creators. A machine learning algorithm can process thousands of images, learn from millions of examples, and make complex decisions in the microseconds between your heartbeats. For these digital minds, human thought appears to unfold with the stately pace of geological processes, while their own electronic cognition races through cycles of perception and decision at frequencies that would overwhelm any biological nervous system. Yet perhaps even more remarkable than the speed of digital time is its ability to transcend the constraints of space and geography. Through global networks that synchronize communications across multiple time zones, digital technology has created virtual temporal environments where simultaneity becomes possible despite vast physical distances. When you participate in a video call with colleagues scattered across continents, you're inhabiting a shared temporal space that exists independently of local clocks and planetary rotation. These digital networks have essentially created artificial temporal commons, shared environments where time itself becomes a medium for collaboration rather than a constraint to be overcome. In online gaming worlds, millions of players coordinate their actions in real time, creating virtual societies that operate according to server time rather than solar time. Social media platforms create persistent temporal streams where conversations begun years ago can be instantly recalled and continued, collapsing the traditional boundaries between past and present communication. The internet has also achieved something that approaches digital immortality for human thoughts and creations. Unlike biological memory, which fades and transforms over time, digital storage preserves information with crystalline permanence. Your words, images, and ideas can exist indefinitely in electronic form, accessible at any moment regardless of when they were originally created. In this digital realm, time loses its destructive power. Yesterday's email remains as immediate and accessible as today's, creating archives of human consciousness that stretch across decades without decay. This persistence of digital information has created new forms of temporal presence that blur the boundaries between life and death, presence and absence. The social media profiles of departed friends continue to receive birthday wishes and memorial messages, creating spaces where the living can maintain ongoing relationships with digital echoes of the dead. These persistent digital selves represent a new form of temporal existence, neither fully present nor completely absent, but suspended in an electronic limbo where past and present coexist. Virtual reality and simulation technologies have pushed the boundaries of digital time even further, creating artificial temporal experiences where the normal rules of duration and sequence can be bent or broken entirely. In virtual environments, time can be slowed to allow detailed examination of rapid processes, accelerated to compress years of experience into minutes, or even reversed to undo actions and explore alternative outcomes. These temporal manipulations provide unprecedented tools for understanding the nature of time itself. Scientists use high-speed simulations to model processes that would take millennia to unfold naturally, while virtual reality researchers experiment with temporal distortions that reveal how deeply our sense of time depends on sensory input and neural processing. In these digital laboratories, time becomes a variable to be adjusted rather than a constant to be endured. Perhaps most profoundly, digital time has begun to reshape human consciousness itself. Our attention spans adapt to the rapid cycles of notification and response that characterize digital communication. Our memory systems learn to offload storage to external devices, creating hybrid biological-digital cognitive architectures. Our perception of duration becomes influenced by the speeds and rhythms of the electronic devices that mediate our daily experience. This creates a fascinating temporal feedback loop where digital technology, originally created to serve human needs, begins to reshape the very temporal landscape of human consciousness. We think faster in response to rapid-fire digital stimuli, expect instant access to information, and experience boredom more quickly when forced to operate at purely biological speeds. As artificial intelligence systems become more sophisticated, they may develop their own unique relationships with time that differ radically from both biological and current digital temporal patterns. Machine consciousness, if it emerges, might experience duration in ways that transcend all current understanding, inhabiting temporal dimensions that exist purely in the realm of information processing. In creating digital time, humanity has accidentally opened a door to temporal possibilities that extend far beyond our original intentions. We sought to build tools that would save time and increase efficiency, but instead we have created new temporal ecosystems that operate according to their own logic, their own rhythms, and their own rules. As you navigate the digital landscapes that surround modern life, you participate in this grand experiment in artificial temporality. Every click, every swipe, every digital interaction places you at the intersection of biological and electronic time, where human consciousness learns to inhabit multiple temporal dimensions simultaneously, bridging the ancient rhythms of neural thought with the lightning-fast pulses of silicon dreams. Beyond the edge of everything you know, beyond the furthest galaxies and the cosmic microwave background, physics whispers of something almost too vast to comprehend. Your universe, with its familiar tick of seconds and march of entropy, may be nothing more than a single note in an infinite symphony of realities, each keeping time to its own impossible rhythm. This is the realm of the multiverse, where theoretical physics encounters the ultimate questions about the nature of time itself. Here, in mathematical landscapes that stretch beyond imagination, scientists have discovered that our cosmic clock may be just one timepiece in an infinite collection, each marking duration according to rules that would seem like magic to minds bound by our particular temporal reality. The story begins with eternal inflation, a process so magnificent in scope that it dwarfs even the Big Bang itself. According to this theory, the quantum vacuum seethes with energy fluctuations so powerful they can spontaneously birth entire universes. These cosmic bubbles emerge from nothing, each expanding rapidly into fully fledged realities, complete with their own space, matter, and crucially, their own unique relationship with time. In this inflationary multiverse, new universes are being born every moment, each potentially operating under different physical laws that govern how time flows and what it means for events to unfold in sequence. Some of these bubble universes might experience time that flows backward relative to ours, while others could have multiple temporal dimensions weaving together in patterns that no human mind could follow. The quantum mechanics underlying our reality adds another layer of temporal complexity that challenges our most basic assumptions about the nature of existence. The many worlds interpretation suggests that every quantum measurement, every moment of uncertainty at the subatomic level, causes reality itself to branch into multiple parallel timelines. Each possible outcome becomes real in its own temporal thread, creating a constantly proliferating tree of parallel histories. This means that right now, as you listen to these words, countless versions of yourself exist across an infinite array of parallel timelines. In some, you made different choices that led to radically different lives. In others, the fundamental constants of physics shifted slightly, creating universes where time itself behaves in ways that would seem alien to your experience. Each of these timelines maintains its own internal consistency, its own arrow of time, its own story of cosmic evolution. The mathematics of string theory pushes these ideas even further into realms that strain the very concept of time as humans understand it. In these theoretical frameworks, our familiar 3 dimensions of space and single dimension of time may be just a tiny subset of a much larger dimensional structure. Hidden dimensions could curl up so small they remain invisible to our instruments, or stretch so vast they encompass realities beyond our cosmic horizon. Some versions of string theory propose that additional temporal dimensions could exist alongside our familiar time, creating higher dimensional temporal spaces where past, present, and future might coexist in ways that transcend our linear experience. In these exotic realms, causation itself might operate according to rules that would seem paradoxical to minds evolved in a universe with only one temporal dimension. These theoretical possibilities raise profound questions about the universality of time as we experience it. Our universe operates according to what seems like a fundamental arrow of time, driven by the increase of entropy and the expansion of space. But this might be a local characteristic, rather than a universal law, a temporal pattern specific to our cosmic neighborhood, rather than an inevitable feature of existence itself. In some regions of the multiverse, time might flow in cycles, with universes expanding and contracting in endless temporal loops. In others, entropy might decrease rather than increase, creating worlds where broken glasses spontaneously reassemble and rivers flow uphill. Still others might exist in temporal stasis, where change itself becomes impossible and eternal moments stretch across infinite duration. The implications of these ideas extend far beyond abstract physics into questions that touch the very heart of existence. If infinite versions of every possible timeline exist somewhere in the multiverse, does free will become meaningless? If every choice has already been made in some parallel reality, what meaning can individual decisions carry? These questions challenge not just our understanding of time, but our sense of purpose and identity within the cosmic order. Perhaps most tantalizingly, some theories suggest that communication or interaction between different temporal domains might be possible under certain exotic conditions. Quantum entanglement could potentially create bridges between parallel timelines, allowing information to flow between realities that operate according to different temporal rules. Wormholes might connect distant regions of the multiverse where time flows at different rates or in different directions entirely. The search for evidence of these other temporal realities drives some of the most ambitious experiments in modern physics. Scientists look for subtle patterns in the cosmic microwave background that might reveal collisions between our universe and neighboring bubble realities. They study quantum systems for signs of interference from parallel timelines and probe the deepest mathematical structures of reality for clues about hidden temporal dimensions. As these investigations continue, they reveal that time, which seems so fundamental to human experience, might be far more varied and strange than we ever imagined. Our universe's particular way of organizing past, present, and future might represent just one possibility among countless others, each offering its own unique perspective on what it means for events to unfold and reality to evolve. In contemplating the multiverse clock, we encounter humility on a cosmic scale. The temporal landscape that contains our entire history, from the first moments after the Big Bang to the far future death of stars, might be nothing more than a brief tick on a vast multiversal timepiece whose full scope extends beyond the reach of imagination. Yet within this almost incomprehensible vastness, our particular experience of time retains its meaning and beauty, a unique thread in the infinite tapestry of temporal possibility. Deep in the heart of physics lies a clock unlike any other, one that counts not moments or years, but the universe's slow march toward its own ending. This is the heat-death clock, and it ticks with the relentless rhythm of entropy, measuring the cosmic journey from the blazing creativity of the Big Bang Bang to the cold silence of a universe where time itself may finally surrender to perfect stillness. The second law of thermodynamics writes the universe's ultimate story in the language of increasing disorder. Every star that burns, every chemical reaction that powers life, every thought that fires across your neurons, all contribute to entropy's inexorable rise. Like a cosmic wound-down spring, the universe expends its energy reserves with each passing moment, transforming the concentrated power of stellar fusion into the diffuse heat of empty space. This thermodynamic arrow of time points toward a far future that stretches imagination beyond its limits. In roughly 5 billion years, our sun will exhaust its nuclear fuel and expand into a red giant, boiling away Earth's oceans and stripping its atmosphere into space. But this local catastrophe represents merely the opening movement in entropy's vast symphony of cosmic dissolution. Over the following trillions of years, all the stars in all the galaxies will follow similar paths to extinction. The most massive stars will explode as supernovae or collapse into black holes, while smaller stars will slowly fade to cold white dwarf remnants. New star formation will gradually cease as the universe's supply of hydrogen becomes locked up in stellar corpses and brown dwarf failures, leaving behind a cosmos populated by cooling embers and gravitational ghosts. Yet even black holes, those seemingly eternal monuments to gravitational collapse, cannot escape entropy's ultimate authority. Stephen Hawking discovered that these cosmic vacuum cleaners actually emit radiation, slowly evaporating through quantum processes that operate on timescales so vast they make the current age of the universe seem like a fleeting moment. A black hole with the mass of our Sun would take longer to evaporate than the number 1 followed by 67 zeros years, a duration that renders meaningless any attempt to comprehend it through human experience. As the last black holes finally surrender their mass to Hawking radiation, the universe will enter its final thermal state. All temperature differences will have disappeared, every source of useful energy will have been exhausted, and the cosmos will exist in perfect equilibrium at just above absolute zero. In this heat-death scenario, time's arrow finally comes to rest, with no thermodynamic processes remaining to distinguish past from future or cause from effect. But even in this seemingly terminal state, quantum mechanics refuses to allow perfect stillness. Random fluctuations in the quantum vacuum will continue to create temporary pockets of order from the surrounding chaos. Occasionally, these fluctuations might achieve remarkable complexity, spontaneously assembling into brief moments of organization that could, over incomprehensibly vast periods, recreate patterns as complex as galaxies, stars, or even conscious beings. These quantum resurrection events would occur with such rarity that describing their timescales challenges the very concept of duration. Yet, in an infinite future, even infinitesimally probable events become certainties given enough time. The universe might spontaneously recreate exact copies of Earth, complete with every person who ever lived, only to have these miraculous assemblies dissolve back into chaos moments later in cosmic terms. Alternative scenarios for time's ultimate fate offer different visions of cosmic ending. The Big Rip proposes that dark energy's acceleration might eventually become so extreme that it tears apart the very fabric of space and time. In this scenario, galaxies would first separate beyond all possibility of communication, then solar systems would be ripped apart, followed by planets, molecules, atoms, and finally the fundamental particles themselves, leaving behind a universe where space expands so rapidly that nothing can maintain coherent existence. Cyclic cosmologies present yet another possibility, suggesting that our universe might be just one cycle in an eternal sequence of cosmic births and deaths. These models propose that the universe could eventually stop expanding and begin contracting, reversing the thermodynamic arrow of time as compression heats the cosmos back toward a big crunch that might trigger a new Big Bang. In such scenarios, time becomes truly cyclical on the grandest possible scale, with each universe, inheriting the thermodynamic legacy of its predecessors. These different endings raise profound questions about the relationship between time and change. If heat-death represents a state where no further work can be performed and no meaningful events can occur, does time continue to exist in any meaningful sense? Or does the cessation of thermodynamic processes effectively bring time itself to an end, leaving behind a static eternity where duration loses all significance? The possibility of consciousness persisting in such far future scenarios challenges our deepest assumptions about the nature of mind and awareness. Could intelligence find ways to survive by exploiting quantum fluctuations, or by reversible computing processes that generate no net entropy? Or would the heat death of the universe necessarily mark the final extinction of all conscious experience, bringing to an end the universe's 13th 8-billion-year experiment with self-awareness? These questions touch the very heart of time's cosmic meaning. The heat-death clock measures not just the universe's journey toward equilibrium, but the potential limits of complexity, consciousness, and temporal experience itself. It reminds us that our brief moment of cosmic awakening, this fleeting era of stars, planets, and thinking beings, represents a temporary rebellion against entropy's relentless march. As you contemplate these vast cosmic timescales, remember that the same thermodynamic forces that drive the universe toward its ultimate fate also power every moment of your existence. The warmth of your body, the firing of your neurons, the beating of your heart, all depend on the very entropy increase that will eventually lead to cosmic silence. In this way, you participate intimately in time's greatest story, a temporary flowering of complexity and consciousness in the universe's long journey from perfect order to perfect disorder, carrying within yourself both the creative fire of cosmic beginning and the patient certainty of cosmic ending. The most haunting thought in all of philosophy arrives like a whisper from eternity itself. This moment you are experiencing now, this exact configuration of thoughts and sensations, has already happened an infinite number of times before, and will happen an infinite number of times again. You have lived this life countless times, made these same choices, felt these same emotions, in an endless cycle that stretches across the vast corridors of cosmic time. This is the eternal return, a concept that transforms the universe from a linear story with beginning and end into a cosmic wheel that turns forever, carrying the same patterns of existence through endless repetition. Here, in the intersection of philosophy and physics, time reveals its most paradoxical face, simultaneously progressive and cyclical, meaningful and absurd, unique and endlessly repeated. Friedrich Nietzsche first articulated this terrifying possibility with crystalline logic. If time extends infinitely into the future, but the universe contains only finite matter and energy, then every possible arrangement of atoms must eventually be exhausted. The random motion of particles will, given enough time, recreate every configuration that has ever existed, including the precise arrangement of matter that constitutes this moment of your consciousness, reading these words. The mathematics of this cosmic repetition staggers the imagination. The number of possible arrangements of all the particles in the observable universe exceeds the number 1 followed by 10 to the power of 120 zeros. Yet even this incomprehensibly vast number remains finite, meaning that infinite time must eventually exhaust all possibilities and begin the cycle anew. You have been born before, lived this exact life before, and will live it again in precisely the same way, an infinite number of times. Modern cosmology has given new life to these ancient ideas through scientific models of cyclic universes. Rather than ending in heat death or cosmic expansion, some theories propose that the universe undergoes endless sequences of big bangs and big crunches. Each cosmic cycle begins with explosive expansion, proceeds through billions of years of stellar evolution and galactic formation, then contracts back to a point of infinite density before rebounding into the next cosmic cycle. In these cyclic models, each universe inherits the thermodynamic and quantum legacy of its predecessor, creating the possibility that not only the overall pattern, but even the specific details of cosmic evolution might repeat across cycles. The same galaxies might form in the same locations, the same planets might orbit the same stars, and the same forms of consciousness might emerge to contemplate their own eternal repetition. The Poincare recurrence theorem provides mathematical foundation for these cyclical concepts, proving that any finite dynamic system must eventually return arbitrarily close to its initial state. While individual events might follow chaotic patterns that appear random, the overall configuration of the system will, given sufficient time, return to approximate its starting condition. This mathematical certainty transforms the universe into a vast machine that must eventually retrace its own temporal footsteps. Yet the quantum nature of reality adds even stranger possibilities to this cyclical framework. In the far future, long after the last stars have died and black holes have evaporated, random thermal fluctuations in the quantum vacuum might spontaneously create temporary structures of extraordinary complexity. These Boltzmann brains, conscious entities assembled by pure chance, could experience brief moments of subjective awareness in an otherwise dead universe. These random consciousness events raise profound questions about the nature of temporal experience in cyclical time. If quantum fluctuations can create minds that remember false histories and perceive illusory presence, how can any conscious being distinguish between genuine experience and temporary thermal hallucination? In an infinite universe with eternal time, conscious observers created by random chance would vastly outnumber those arising through natural evolution, making your current experience statistically more likely to be a quantum illusion than genuine biological consciousness. The implications of eternal return challenge fundamental assumptions about meaning, progress, and individual significance. If every choice has been made infinite times before and will be made infinite times again, does moral responsibility become meaningless? If human history repeats in endless cycles, can there be genuine development or growth, or are we trapped in patterns that never truly change? Some find terror in these possibilities, the notion that suffering and tragedy recur eternally, that every mistake will be repeated countless times, that no progress is permanent. Others discover a strange comfort in eternal return, seeing in it a form of immortality where consciousness persists through endless cycles of cosmic time, where every moment of joy and beauty is preserved forever in the eternal wheel of repetition. The cyclical nature of quantum systems adds another layer to these temporal paradoxes. At the smallest scales, quantum states can return to their initial configurations with mathematical precision, creating perfect cycles that repeat with clockwork regularity. These quantum loops might serve as temporal seeds that influence the development of larger-scale cycles, creating nested hierarchies of repetition that operate across multiple temporal scales simultaneously. Perhaps most remarkably, the concept of eternal return transforms the relationship between time and consciousness. Rather than being passive observers carried along by time's current, conscious beings become active participants in time's cyclical structure. Your thoughts and choices, repeated across infinite cycles, become permanent features of the cosmic pattern, eternal elements in the universe's endless dance of repetition. The eternal return also suggests that time itself might be fundamentally circular, rather than linear. Instead of progressing from past through present to future, temporal flow might trace vast cosmic circles, where the future eventually curves back to meet the past. In such a universe, causation becomes cyclical, with effects eventually becoming their own causes across timescales that span cosmic epochs. As you contemplate these possibilities, remember that regardless of whether eternal return represents literal truth or philosophical metaphor, it reveals something consciousness stands at the center of time's greatest mystery, both creating the experience of temporal flow and somehow stepping outside that flow to observe its own creation. This is the observer's paradox, the strange loop where awareness becomes both author and audience of time itself, writing the story of duration while simultaneously reading it from a perspective that seems to exist beyond the narrative it creates. Every moment of your conscious experience presents this fundamental puzzle. Your brain consists of billions of neurons firing in complex patterns across mere milliseconds, yet somehow from this biological clockwork emerges the rich, unified experience of temporal flow. The warmth of sunlight on your skin, the melody of a familiar song, the taste of morning coffee. All these sensations arrive at your consciousness through neural pathways operating at different speeds, yet you experience them as a seamless, integrated present moment. This transformation of scattered neural events into unified temporal experience represents one of the hardest problems in all of science. Physical processes in your brain unfold according to the objective time measured by atomic clocks, yet the subjective time of consciousness operates according to entirely different rules. Minutes can feel like hours during moments of crisis, while hours disappear like seconds during states of deep engagement. Consciousness creates its own temporal landscape that bears only loose correspondence to the physical time in which neural processes actually occur. The binding problem in neuroscience reveals how actively consciousness must work to create even the illusion of temporal unity. When you see a red ball bouncing, your visual system processes color information in one neural pathway, motion in another, and shape in a third. These different streams of information travel at different speeds and arrive at consciousness at different moments, yet your brain weaves them together into the seamless experience of a single moving object. This temporal binding requires exquisite neural coordination, with oscillating brainwave patterns synchronizing across distant brain regions to create windows of integration where scattered information coalesces into unified perceptions. Your consciousness doesn't passively receive temporal experience. It actively constructs it moment by moment from the chaos of parallel neural processes operating on their own independent timescales. Deep meditation and altered states of consciousness reveal just how constructed and malleable this temporal experience really is. Advanced practitioners report entering states where time seems to stop entirely, where hours of meditation feel like single eternal moments, suspended outside the normal flow of duration. Others describe experiences of temporal expansion, where consciousness seems to stretch and encompass vast ranges of time simultaneously, perceiving past, present, and future as facets of a single, multi-dimensional now. These altered temporal states suggest that ordinary time consciousness, the linear progression from past through present to future, represents just one possible mode of temporal awareness among many. Under the influence of certain practices or substances, consciousness can reorganize its relationship with time entirely, creating experiences that transcend the boundaries of normal temporal perception and reveal the constructed nature of our everyday temporal reality. The observer effect in quantum mechanics adds another layer to these temporal paradoxes. According to some interpretations of quantum theory, the act of conscious observation plays a fundamental role in collapsing quantum superpositions into definite states. Before measurement, quantum systems exist in mysterious superpositions of all possible states simultaneously. Only when conscious observers interact with these systems does reality crystallize into specific, determinate outcomes. After traversing the vast landscapes of cosmic evolution, diving into the quantum depths where reality dissolves into probability waves, riding the curved spacetime of Einstein's universe, exploring the neural networks where consciousness constructs its temporal experience, and gazing into futures where black holes evaporate into nothingness, we arrive at the question that has haunted every chapter of this journey. What is time, really? The answer, like time itself, proves beautifully, mysteriously elusive. Perhaps this elusiveness is not a failure of understanding, but a fundamental feature of time's nature, a hint that time is not something that exists independently, waiting to be discovered, but something that existence creates in the very act of being. Consider the profound simplicity of a single heartbeat. In that rhythmic pulse lies the convergence of every temporal mystery we have explored. Your heart marks biological time, evolved through eons of stellar nucleosynthesis that forge the calcium and potassium coursing through your cardiovascular system. Each contraction operates according to quantum mechanical processes in cellular membranes, while the electrical signals that coordinate the heartbeat travel at speeds determined by relativity's universal constants. That heartbeat exists as a specific moment in space-time, eternally embedded in the four-dimensional fabric of reality, yet it also flows forward into an uncertain quantum future, where the next beat exists only in probability until the moment of its actualization. Your consciousness weaves this physiological rhythm into the subjective experience of temporal flow, while your memory preserves each heartbeat's echo and your anticipation reaches toward future beats not yet realized. In this single biological event, all of time's mysteries converge: the cosmic evolution that created the elements of your body, the quantum processes that enable cellular function, the relativistic spacetime in which your heart exists, the neural mechanisms that transform physical rhythm into conscious experience, and the thermodynamic processes that will eventually bring all heartbeats to their final silence. Time might be the universe's way of preventing everything from happening at once, as physicists sometimes jest, but this seemingly simple statement conceals profound depths. Without temporal sequence, cause and effect become meaningless. Consciousness cannot form memories or make plans, and the universe collapses into a static configuration where no change, growth, or development can occur. Time creates the space for becoming, for the endless dance of possibility and actuality that characterizes existence at every scale. Yet time might equally be consciousness's way of making sense of change, a cognitive construct that minds impose on the flux of experience to create narrative coherence from the blooming, buzzing confusion of sensory input. In this view, Temporal flow emerges from awareness rather than underlying it, with consciousness serving as the author of duration rather than its passive recipient. Perhaps most intriguingly, time might be something far stranger than either cosmic feature or mental construct, an emergent property that arises from the interaction between information, energy, and awareness across multiple scales of reality. In this view, time becomes a bridge between the physical and the mental, the objective and the subjective, the quantum and the classical, a fundamental organizing principle that allows complexity to emerge from simplicity and consciousness to arise from matter. The thermodynamic arrow of time, with its relentless increase of entropy, suggests that time is intimately connected to the flow of energy and information through complex systems. Yet quantum mechanics reveals that at the deepest level, temporal sequence might emerge from the collapse of probabilistic wave functions into definite states, a process that some interpretations connect directly to conscious observation. Perhaps time emerges at the intersection of these domains, neither purely physical nor purely mental, but something new that transcends both. Every moment contains within itself all of time's paradoxes. The present moment you are experiencing now exists as an eternal point in the space-time continuum, forever embedded in the four-dimensional fabric of reality. From the perspective of relativity, this moment has always existed and will always exist, as permanent and unchanging as a landmark in geography. Yet from your conscious perspective, this same moment flows like a river, carrying you inexorably from past toward future in a stream of continuous becoming. This temporal paradox, the simultaneously eternal and flowing nature of now, might be time's deepest truth. Each moment both exists timelessly in the space-time manifold and flows dynamically through consciousness, creating a reality that is neither